Hi, welcome everyone. Nice to see you all again. It's another week here. A few of us are back in the EOAS area. Just here. If anybody wants to join, they're welcome to join at the big table. I've got my first class today, so I'm excited. I was thinking about, Liz was joking with me this morning about taking one of those like first date school pictures where you like have those like people are holding up their signs and we're like, oh, who's your teacher this year? And it'd be like me.
Yeah, we could get a 8-foot by 8-foot blow up and put it in the GIF room. That would be cool.
Anyway, so as always, if you got some quick reports, go ahead and add yourself there. A couple of agenda items. We have another SimPEG seminar tomorrow with Xiao Long at 2 p.m. Pacific time, if I'm correct. Pretty sure that was the time. Lindsay got the newsletter sent out. So you guys all probably saw that this morning or yesterday morning. Yeah. I all saw that come out. So just a few quick things from there. Lindsay, I think we could probably also talk about that. You had sent out an email about from MTNet about the CSAMT code. I'm looking for a home for that. We talk about that too, if we can. I don't think we'll have too much else today.
That sounds good, Joe.
As far as me, for some quick reports. Not too much SimPEG-ish related. A few little things here and there with the tetrahedral mesh stuff, the Simplex Mesh. It'll just little pieces here and there left to implement for it, and it should be pretty good to plug into SimPEG. So I'll be excited to get that plugged in and trying it. Just a few things like a few more little interpolation matrices, a few more like I need to implement like a cell gradient stencil so we can do some inversions with it. Just simple things like that. But it should be nice. The interpolation thing is just a little bit more work than everything else, like being able to arbitrarily interpolate it. I've got ideas about how to do it. Like the nodal-based interpolation is easy. Edges and faces take a little bit more thought. Cell-centered interpolation can be challenging to implement properly with like second-order convergence and stuff.
But Joe, do we really need an interpolation for that mesh? Because I think the beauty of that unstructured mesh, you can actually define the node at the data
location you want it. Yeah.
So
I mean, hopefully not, but it should. We can support it, and it's like a lot of the code in SimPEG uses that, like uses those matrices under the hood to like interpolate to receiver locations.
Right. Yeah.
So it might not be super important that they're like second order convergent or anything. But we just need to at least have them there.
Right.
Need to be able to call get interpolation matrix.
Right. Got it.
Other than that, I don't really have too much SimPEG related over the last week. Does anyone else have any other quick reports, things they've been up to?
Not too much, but maybe just a check in on if we're going to try to merge the discretized API stuff.
Yeah. So we keep talking about it. We're going to get it in. We need to set up a way to, should we just do it on Twitter or something? I don't know where else to do this thing where we just choose a simple logo.
Well, do we
Um,
have like a menu of logos or a place? I mean, because I think we could do it in Slack, like, and also put it up on Twitter, but I don't know if there's like a document right now that we have that everyone can look at and see, like, this one is number one, this
Yeah.
one's number two.
I mean, I
Or
just
like-
have those three options that I had put out before. If anyone has any other thoughts or things they'd like to see, let me know. I'll put it on there. We can start that up this afternoon.
You do it as a Google form, just say like,
Yeah.
which one do you like, A, B, or C? And then we figure out what the favorite is, and then we choose that.
Yeah, democracy.
Sure.
Do you want to do it as a Google Doc? So if somebody does feel creative and inspired this week, they can add something there. And we could do a little poll on Slack.
That sounds good to me. I'll put up a Google Doc and then put those three things in there that I've got so far. And go on. Okay. Anyone else? I know it's just if you want to give us some quick updates on what you guys have been up to too, I don't mind that. It's been a while since we've seen some of you.
To try to deal with the normalization of the cell volumes. But I think Mike is going to be touching it because I didn't look at the PGI part of regularization. And then yeah, that's kind of give you the starting point to refactor the whole classes. But it's a start. So yeah, if you want to take a look, Joe or anyone else, do a review.
Mhm. I feel like we need a nice way to just ask it for, like, we should have a thought about where that volume normalization thing comes into play at, because it, like, depending on like the maps, right, it can be weird where it should actually be. It's like sometimes like if it's an active versus inactive cells, it can be odd. If it's it can be an odd thing. If it's, I mean, I guess the reg
Active volumes. The reg knows about the active volumes. We just
Yeah,
need to
reg mesh.
hold the look at the PR and tell me what you think. Yeah.
Yeah. Okay then. So that should be enough. Then just having the reg mesh pull it from there, because that's the mesh that we're doing the regularization on, right? And it should know it even in cases of like if we're doing parametric inversions and things, it should know what mesh we're on.
Yeah.
Or like 1D and 2D should be okay.
Is really in the sensitivity weight directive where now it's just normalizing it on the spot rather than
Yeah.
expecting it.
It should be good. Okay.
Kind of speaking of that, would it be worthwhile to actually write up them? Because I think I actually still don't exactly understand what the sparse inversion does. Because like there's a subtle point whether you take into account the volume or use a stencil. Maybe I think this is probably an opportunity to at least write that up, what it does at this point, and make a clear distinction, like how it's different from TICNAV. Because yeah, I think maybe most of the user wouldn't know. I'm not sure that's like they're really required to know, but I think it would be nice to have some place that we kind of document that and provide what it does.
I mean, we talked about this multiple times already, but basically the idea is that we can collapse all those regularization functions into a one. And then the only difference with TICNAV and sparse right now is just that auto normalization for alpha S, right? So we can collapse it all and just, throw a warning. If you use norms and unnormalized, then you just throw a warning to the user. Otherwise, the TICNAV is just unnormalized and the other one is normalized. That's it. It's the only difference. So there's no reason to have multiple classes. It's redundant code and it's overly complicated.
Right. So that's sort of the point. Like then if that's like generalizable, then let's actually like would it be kind of writing up that as a like a small document?
Reroute the class so that it's obvious what's happening.
Yeah,
Let's
that's
scrap those classes and then make one regularization function. That's it. It's going to be much simpler for everyone to understand.
Yeah.
Yeah, I see. I see.
Or if anything, like these subclasses, they're just minimal changes, and just minimal necessary stuff to the base class.
GI, you know, is a subclass, and then probably going to do a vector regularization instead of having to build it every time. Just, you know, stack multiple regularization on top for vector models. But yeah, those are just subclasses. I mean,
Yeah. Okay.
Okay. Anyone else?
Is my microphone working now?
Yeah, I can hear you.
Okay, yeah. Yeah, I didn't get to anything while I was out in the field. I thought it was going to be a little bit of a break, but I ended up having to lead the crew, so that didn't work out. But I'll get back into the PRs and the code stuff here shortly. But was back here at the beginning of the week and started diving back into the parallel computing. We have the Kubernetes cluster now set up. Yeah, we want to compare that to the MPI solution. I got the MPI solution, like kind of what we talked about there before I left there, Joe. And now the slow part is having all the processes loading in the data at once from one access point over the network. So yeah, sorry, there's always a bottleneck somewhere. But yeah, we're just going to see what the Kubernetes stuff, just by passing it around normally, just how we have it set up, just to see what it does. Should be interesting. But yeah, more to come on that. Now that I'm back should be for a while.
Yeah. Well, I hope everything did go well down there.
Yeah, well enough. It was a lot steeper than I would have hoped.
It's good. So with that, I think we can have Lindsay, if you want to chat about the Joanna MT or CSA MT code that they sent out on MTNet.
Sure, I don't have too much to say on this other than I think it really, so I don't know if folks saw that first, I guess. Let me just pull up that email. So what prompted this is Richard Smith sent out an email saying he has Peter Videlt's code for a thin plate, a thin dipping dike. And sort of, you know, some of these solutions are really useful for just being able to test things and also maybe even perform kind of simple inversions. And, you know, we've got kind of the EM1D components in SimPEG and Joanna, and just kind of wanted to prompt this is like, what other solutions do we think that we should have that would be really useful to the community? I mean, we can come up with like a laundry list and prioritize. I don't think we need to start like a massive effort to just be implementing everything today, but I think it would be useful to have just a bit of a list of like, what are the solutions that are sort of classic and really useful and things that we should have. And then we can kind of, as time progresses and as we have applications that could make use of these solutions, just go ahead and implement them. And yeah, but I was thinking just something to track that. We could even start a GitHub issue or something like that. But mostly just wanted to prompt a bit of discussion and thoughts on any solutions that we should have.
I do like having these like simple solutions in there. It's nice. It's good to test them against it. Some of the other things I thought about adding to it are like potential field solutions for like simple bodies. I think those would be useful because even, you know, just kind of like mean, like rectangular prisms are great. Like they're simple, spheres are simple, like just simple bodies that we can use. And my other thought there is that since we've got a bit of compiled code inside there now, or when we can, like when we make use of it, we can do the same thing for some of those, like let's say we have we can do a fast potential field modeling, like where we give it a bunch of node locations and it calculates the components for those instead of doing them in Python right now. And then like the specialized function would just be, okay, well, it knows how to use those things to do the cube or the rectangular prism. We just have it call that and then have like more general things that we could potentially call from SimPEG that would call that compiled code to generate those things faster. This like trying to move more of the analytic stuff that's in SimPEG to there.
It would be worth taking a look at what's in Fadiando so that we're not duplicating efforts. I think they might have some simple prism solutions, and so we might be able to either reuse or even sort of contribute upstream there. But yeah, totally agree.
On the EM front, always that conductive permeable sphere in a half space is useful both for frequency and time, as well as for plane waves and a dipole source.
I have I know I had like a full, like a half space anisotropic DC resistivity or a layered half space anisotropic DC resistivity modeling. So I think that, I mean, it could be useful, like just have like 1D DC resistivity modeling in there. I don't think it is right now. I'm pretty sure it's not in there, so that could be something useful to add.
Yeah, so maybe in terms of next steps, we can start an issue and maybe link a Google Doc might be easiest, just so that we can sort of capture links and just have it be pretty editable right from the start. And then we can maybe turn that into something that's a little more actionable later on.
Mm-hmm. Anyone have any other requests for things to put into Joanna?
The thin C solution is actually pretty like kind of appealing to have. It's actually complicated. I'm not sure it's relevant for Joanna. You actually need to solve this integral equation to have a general thin solution. So, but I think would be this is one of my bucket list to like something that I want to have. But would be great to be in Joanna. But the question that I had, like, there's some so it's actually complicated, and there are some old Fortran code. So the question is, do we really want to rewrite like that from scratch and then turn that into Python and kind of store that as like archive as a Joanna, or just want to revive that old Fortran code and compile it and use it whenever we want? Yeah, I think that that email also brings up the same question Richard Smith had, like, okay, here's Fortran code that I wrote. Do we want to rewrite that and kind of have a fresh Python code kind of doing the same function for that, or just kind of wrap up his Fortran code and somehow compile it and use it in Joanna?
That's a really good question, Saudi. And I think the only potential challenge there, which is probably can be navigated, is how it's licensed, and it's probably, and if we sort of have permission to distribute it or not. It certainly sounds like we can get access to it, but I don't know kind of the ins and outs of us like distributing that with an open source package when it was, yeah, different licensing conditions. But that's something we should I mean, it would be useful to get that code anyways from Richard Smith. And so we could see if there's a way to prompt that conversation.
Yeah.
Well, since it comes from Richard, he might have some comments on that. But basically, this code is kind of freely distributed. I'm sure Peter would have liked that. And most of these codes are really old. I mean, we're talking 30, 40 years at least for some of these codes. So yeah, I can't see anybody would object, but I guess that probably need to dot I's and cross T's just to make sure that nothing unexpected happens. But I can't even foresee a possibility of that for these really old Fortran codes. Yeah, can't see it.
It is getting like it's something like we could think about just writing Fortran like wrappers to call the Fortran functions. I haven't seen the code. I'd have to look at it to see what we could do with it or what would be best to be done with it. But if it is all old 1980s Fortran code, it's likely Fortran 77 based, so it's just a very older. Like you just get older versions of Fortran. They get harder to interface with newer things. So like you do bring up another point that it's like an integral based solution, an integral equation based solution, right?
Right. Yeah, I have some connections with like some of the old like Korean EM geophysicists who actually wrote like some of this like analytic functions, and they probably like archived on their old Fortran code. And somehow I hope that I can capture that, because once they're gone, that's gone. So, and actually it's a lot of work to rebuild that analytic function. It's not necessarily trivial, like probably even harder than writing the 3D code. So yeah, it was my hope, but not exactly sure what's the best way. But the first time I think basically asking them, and can you actually provide the Fortran code and make it accessible to everybody? That seems a good start. And if needed, we can rewrite that maybe. But that seems a good starting point, collecting and archiving.
Well, that seems like a good step. I'm happy to write an email to Richard and just kick off the conversation and see if we can, well, first get access to it and then think about distributing it.
Yep. I mean, I'm fine with including integral equation stuff in there in general, because we've got like other semi-analytic based things.
Yeah. As we go, I can also contact some of the people that I know, and they probably, it's old code, as Doug said, like at one point it's probably licensed to something, but at this point they're probably willing to open source it, I guess, in general. So I could also send a couple of emails to them.
I'd actually be surprised if it was formally licensed by anybody. It's just, you just have this code, you keep it under wraps, you don't distribute it. But yeah, license agreements were probably not really very in vogue those days.
Okay. Well, I will. Once you post the link to that Google Doc, we can probably post it in. I don't know. Is there do we have a Joanna channel on Slack?
No.
Gotcha, it's on there. So it's also in the agenda. There is a link to it for now. It sounds like a good plan. We'll add stuff to that. We'll get in contact. Sounds good. Yeah. Anything else anyone would like to chat about? If not, I think we're good to go until next week. So have a good week, everyone. Have a good weekend.
Bye all.
Bye.
Have a good lecture this afternoon. Enjoy. Remember, you're the teach
Oh.
and they're the pupes.
Yep, yep.
Good luck, Joe. Bye.
Bye.
You'll get it.